Let's look at page 11 in your packet, measuring pressure. A manometer is one way of measuring pressure. It's one type of tool we can use to measure pressure. So they're saying that there's a flask connected to a manometer. So this U-shaped part is the manometer, and then it's connected to a flask. The other end is open. It's asking to calculate the pressure of gas in the flask that's connected to the manometer. The pressure in the room that the flask is in is listed as P room. So here we go. We got P room, 730 millimeters of mercury. This liquid that's in here is mercury. Mercury is a metal that's liquid at room temperature, and historically it was used in this situation because of its density. And if you're interested in that, I recommend further reading. So what do we do here? You've got 730 millimeters of mercury of pressure in the room, and so this open end is into the room. And in the room we've got atmospheric pressure, and we'll tackle that problem number 3 down here. But what do we mean by atmospheric pressure? So here we've got 730 millimeters of mercury worth of pressure pushing down inside this tube, pushing down inside this tube, and pushing down inside this tube. You've got the question mark here of, well, what do we put as their number inside this tube, inside this flask? And so we got to look at what we've got here. We've got these other numbers, 127, 84, 130, 26. All of these are also millimeters of mercury. And let's just take a look at this thing logically. If you look at this, you'd imagine that if these two heights are equal, that there's the same amount of force pushing down on this side as this side. Right? If it was uneven, it would look more like this. This one would be pushing more, and the liquid would squirt up into the flask, or towards the flask. And if in this one, this side's got to be pushing harder, because the liquid is kind of losing this tug-of-war battle and it's getting pushed out of the tube. So we've got to look at the difference in height here. That's the key thing to notice. And over here, there is no difference in height. So we'll look at that one in a second. So we're going to call this height H, and I'm going to just show that it's from line to line. We got these two numbers. If we want to know the difference between the two numbers, what do? You subtract. That word difference means subtract. So I don't know what negative pressure is. Like that just kind of doesn't make any sense. And we'll get more into that a little bit later on in a classroom discussion. But 127 minus 84 will give us a positive number. So let's try that. 127 minus 84. Remember, these are millimeters of mercury. I'm not writing the units here, but 127 minus 84 gives you 43. So if we've got 43 millimeters of mercury difference here, that means the difference in pressure has got to be 43. But which direction? So if we take 730 millimeters of mercury pushing down, this 730 is losing out. So that means this has got to be a bigger pressure. So that means this, if we add, that means let me say it a better way. If we add 43 to 730, that's got to be what the pressure is in here. So let's check it out. 730 millimeters of mercury plus 43, that's going to equal what? 730 plus 43 is 773 millimeters of mercury. And that is what it ends up in here. Let's take a look at B. Now we're going to get the difference here. 130 minus 26. That will give us 104 millimeters of mercury. And if we've got 730 in the room, what are we going to do with that? 730 in the room, it's winning. It's pushing harder on this liquid. So that means that the amount inside here is going to be less than the room pressure or the atmospheric pressure. So if we added in this case, that means we're going to have to subtract in this case. So we're going to take that room pressure, 730, we're going to subtract the 104 difference in height. So 730 minus 104, we get 626. So 626 millimeters of mercury. Awesome. What about this one? I mean, hopefully you're guessing by this point that, well, if it's 730 in the room and there's no difference here, well, it's got to be 730 in here. And if you guessed that, you guessed correctly. But the math works out too, right? If we have zero, if we have sort of like a formula we're developing, you take the room pressure and you subtract or add the difference. Well, if the difference is zero, you don't have anything to do. So you just have 730 plus 0 minus 0. It kind of doesn't make sense either way. But let's say that it's plus 0 equals 730. So that's your number. I'll leave these for you to try, but the process is exactly the same.